is a fixed beam. There are three unknown reactions. All of you know this is a roller support, one unknown reaction. There is a free end and the load. There is a UDL load and there is a concentrated load. Of course, we have to neglect horizontal force. Since in the beams, when we analyze frames, we will be including horizontal effect also. So that will come in the second part when we do the frame analysis in this course. So you know equilibrium equation. There are two equilibrium equations. This equilibrium is discarded and number of unknown forces which are of interest are B, Ra, Ma. RH is neglected. So three unknown forces and two equilibrium equations. Static degree of indeterminacy 3 greater than 2. Static degree of indeterminacy is 1. Now kinematic degrees of indeterminacy, as I told you, when joint deflections and joint rotations are of important to us, I have to consider I have to calculate the kinematic degrees of indeterminacy for that beam. So in this beam, this is a fixed support where theta A and delta A, deflection and rotations will be 0, right? So I would say because of fixed and theta A, delta A is 0, these are the known quantities. So these are not unknown. So I will not include in kinematic. When I calculate kinematic indeterminacy, I will not include it. Second, you can come here, second joint at support B, roller support. Now you know there is a vertical reaction here. You can't actually calculate deflection. Vertical deflection is known to us because I know roller support cannot translate vertically. It cannot translate vertically. Vertical deflection will be 0. So delta B will be 0. But there is a rotation because it is a roller support. So this rotation theta B roller support will cause this left span and the right span rotated. Now again, please understand because of uniqueness of displacement or rotation quantity, this theta B and this theta B cannot be different because of the integrity of the structure, continuity in the structure. Theta B of span AB at end B and BC at B end, theta B cannot be different. So I have shown the deflected shape of this beam and rotated shape of this beam. You can see here at theta B in both the span, theta B, it will cause the rotation in both the span. It will be same, theta B is same. So one kinematic indeterminacy is unknown. What is unknown? Rotation here. That is rotation, value of rotation is not known to me, it is unknown. So I would call this theta B is unknown quantity. And I can put it in the form of kinematic indeterminacy. Now come to support C. Of course, it is free and it is not supported. All of you can see it is free and it is not supported. Okay. So what will be the kinematic degrees of freedom? You can also use word degrees of freedom or kinematic indeterminacy. Vertical deflection of the free support is not known to me. Whatever unknown quantity, I can put it in one category. And also there will be a rotation. You can check this experiment by, rotating the paper. You can check this where there is a rotation as well as along with rotation and deflection. So free support will have rotation as well as deflection. So here there are two quantities and support B can rotate, so 3. So you can now write down theta A. I have not written delta A also. You can write here delta A. Theta A is known. I know the value. That means it is known. I don't have to worry about calculating it because it is 0. I know at support A, theta and delta A is 0. So this cannot be considered as kinematic indeterminate variable. This is kinematically known variable. Okay, known, 0 value. So only in this beam, only unknown variables are theta B, unknown displacement variables or rotations are theta B, theta C and delta C. So 3 unknown displacement and the rotations. So that in this structure, kinematic indeterminacy of this structure is basically 3.